Okay, so today we're going to talk about momentum. Momentum is the mathematical equivalent of Newton's third law, although Newton himself never discussed directly momentum. What momentum says is that the linear motion of an object of a certain mass, a certain velocity, will carry with it a property to continue doing what it's doing. It's inertia of motion. And so an object in motion wants to stay in motion because not only its mass, but also its velocity. So you can have a light object traveling really fast, or you could have um, a heavy object traveling really slow, and they can interact with each other and maintain their momentum. The SI units for momentum are kilograms because mass is measured in kilograms and velocity is measured in meters per second, so we get the units meters per second. This is a vector quantity, and so we have to add things together like we have always done with vectors. When we are talking about momentum, we find that, again, in its simplest form, it is the inertia of motion. Newton himself never used the word momentum, but we strongly believe that when Newton said an object in motion stays in motion, an object at rest stays at rest unless acted on by a force, he in his mind was thinking about the concept that we today call momentum. He may have thought momentum was so obvious that he just never stated it. It interchanged the word momentum and motion back and forth. And so when we are dealing with vectors, we sometimes have to break them into their quantities, and their x quantity and their y quantity. And if we follow the rules we've always followed with vectors, we will be perfectly fine. We need to remember, though, if I have an object, just do a quick calculation here, that is traveling at, let's say, 40 meters per second and has a mass of 3 kilograms, this object would have a momentum, P equals mv. P would equal 3 times 40, or 120 kilogram meters per second. Now, if I have a different object, and let's say this object has a velocity of 10 meters per second, but has a mass of 12 kilograms, when I figure that out, P is equal to 10 times 12, or 12 times 10, I end up with the same 120 kilogram meters per second. So I can have an object go fast, or I can have an object have a lot of mass. That's how I'm going to calculate out my momentum. What we're going to do with that momentum, we'll talk about in future videos or live in person. And what we'll find that to be is that the concept of momentum, or the change of momentum, helps us understand forces, and that momentum itself is one of the 3 conservation laws in nature: conservation of energy, conservation of momentum, conservation of angular momentum. If one thing slows down, something else must speed up, is the basis of momentum. Again, if you have any questions, please let me know, and I'm going to ask you to try some problems along the way. Have a great day.